Here we are, can you believe it? Unit 3, Lesson 5 already. How the time flies. Alright, so what does absolute value mean? It really means a distance from 0 when there's nothing else inside the absolute value bars. If there is, well, that moves the center. But basically, we think of absolute value as a distance. So absolute value of x equals 3, well, negative 3 or negative 3 could be x because they're both 3 units from 0. Now, they're just points because there's only 2 numbers at work. With inequalities, there's a range of numbers. So, with the less than, it's all the numbers that are within 3 units of 0. 3 units or less. Well, actually, not or equal to. So, anything less than 3 units. So, that's going to be from there to there. Now, if it's less than or equal to, we're allowed to include the endpoints of 3 and negative 3. Greater than are all values that are more than 3 units from the center. So, starting at 3 and going further to the left or to the right. And I said 3 units from the center. If there's operations inside the absolute value, then that moves the center, but we still think of it as a distance from something. You'll see that in the very last problem of the notes here. So with these, we're going to start at the 3's and point outward. Everything that is more than... Sorry about that. So we're going to start here. That's the answer. And then if it's filled in, because it's greater than or equal to. But those are things that are at 3 or further away from 0. Sorry about the little volume thing. You know, I'm a hack. I'm doing the best I can, guys. All right, so that's a process. Make sure you read those. Pause if you got to. And then let's solve a couple of these. So we're thinking typically if it's an absolute value less than a number, that's going to be an and problem. That's going to be the barbell looking thing. All right, it's going to be within 2 endpoint values. If it's absolute value greater than a number, it's an or problem. It's going to be all the values outside those 2 boundary values. Also copy that example down because that's going to be your typical prototype there. Whoa, hey now. Got away from me there. So, shucks. I'll deal with it. I don't have time to make another one of these. All right, so let's solve this. First, we're going to isolate the absolute value. I divide by 3 on both sides. All right, cool. Good, great, grand. There we go. Now, I got absolute value less than a negative. Now, that's kind of weird. Think about absolute value. It's supposed to be a distance. So, the absolute value of anything, like I'm writing here, is always greater than 0. Absolute value, no matter what you plug in there, you're going to get something equal to 0 or greater. So, it's always going to be greater than a negative. So, it's never going to be negative. That means this is actually no solution. There's no way for an absolute value to be less than a negative. All right, so here we isolate the absolute value. I'm subtracting the 5 on both sides. I still have the negative out front to deal with, so I'm going to multiply both sides by a -1, which means I need to flip the inequality. And now my absolute value is greater than some negative. Okay, absolute value is always more than a negative. So, right, it's always equal to 0 or greater. You can't have absolute value of something be less than a negative. So, this is all real numbers. And sorry for the lengthy video, but deal with it. So in this last one, so for the graphs, there's no graph because there's no answer. For this one here, the graph is all real numbers, so you just cover the whole number line with a circle, or with a line. And then click the next video to get the rest of the notes.